Welcome to today's physics class with MPQs. Yes. So today in today's class we are going to discuss about heat or thermal energy. Heat or thermal energy. You can see it up here. Heat is meaning of heat. Heat. Talking about meaning. Definition. Definition of heat. Heat, also known as thermal energy, is a type of energy that flows from a body or region of high temperature to that of a low temperature. Heat is a type of energy that flows from a body or region of high temperature to another of low temperature. Heat is a form or type of energy that flows from a body or region of high temperature to that of a low temperature. This means that heat is energy that is always in motion. Energy that is always in motion or on transit. So you can also redefine heat as energy in motion. Definition 2, it is energy in motion. So what this means is that there is no such a thing like heat of a body over a period of time, because heat of a body changes with time. So we can only calculate the heat of a body, the change in heat of a body in any given period of time. So heat is a form of energy or a type of energy because it has the capacity or ability to do work. Remember that energy is the ability to do work. So heat can do work. Heat can do work. And we see that in welding. Heat can be used to weld materials, to join materials together. Heat is vital in cooking. It helps foods to cook. Heat can be used in cutting materials. Heat can be used to actualize melting. Heat can be used to dry materials. Heat can be used to do all kinds of functions, and it can be converted into other forms of energy. Heat is applied in DNA testing, and the heat is important in balancing our system, our body temperature. So you can see how important the study of heat is. You can see how important it is. And the definition: heat is a scalar quantity. Heat is a scalar quantity because it has magnitude but no direction. It is a scalar quantity and it has an SI unit of joule. Its SI unit is joule. Its SI unit is joule. It can also be expressed in the unit of calorie. 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 The cal unit. The cal unit, of which 1 calorie is about 4.18 joule. 1 calorie is about 4.18 joule. So these are the units of heat, and this is the SI unit of heat. Now, when we come down to measurement of heat, how to calculate, measure heat, measurement of heat. Measurement of heat energy. It is important to measure heat. The instrument for measuring heat energy. Instrument for measuring heat. Instrument for measuring heat energy is called calorimeter. Calorimeter. What's calorimeter? It is the instrument for measuring heat energy. Put it down. This instrument consists of a metal cylinder a metal cylinder, a metal pot. A small metal pot, usually made of copper or aluminum. Aluminum is used in making it. And then the frame, the cylinder or the pot is insulated outwardly, which what we call lagging. We call it lagging. It is called lagging. Lagging means insulation. Insulation of the calorimeter using a bad conductor of heat to cover the whole body of the aluminum pot. That is what we call lagging. And it is done so that there will be a reduction or prevention of heat exchange between the instrument and the surrounding. What determines the direction of flow of heat is temperature difference. Temperature difference. Heat can only flow between two bodies or regions of space, provided there is a temperature difference or temperature gradient between them. Alright. Having told the instrument for measuring heat, we now move over. Still on this, look at the instrument. This is the calorimeter, and this is the insulation. This is the insulation. Of course, the insulation persists up here. And there is a hole here that contains a thermometer. This is a thermometer. And there is another one here that contains a stirrer. A stirrer. Supposing we have a liquid here, such as water. You have a liquid here, such as water, at a normal room temperature of 25 degrees Celsius. Then an object is heated. Let's say a solid metal is heated and quickly transferred into this. You discover that the initial temperature, θ1, will increase to θ2. The temperature will rise to θ2. Immediately a hot substance is brought in here. The temperature of the liquid will rise. Of course, we can now measure the heat added to the water. We can calculate it. That brings us to calculation of heat. Calculation of heat. In this experiment just described, the quantity of heat absorbed by this substance, the water here, depends on mass. Quantity of heat absorbed or given out by a body, a substance, varies or depends on these following factors. I, initial and final temperatures. Tag θ1, θ2, or T1, T2. II, it depends on mass of the body. The amount of heat a body can absorb depends on the mass, because mass is the quantity of particles that make up the body. It depends on the mass. A body of large mass would absorb more heat than a body of small mass. Take that. A body of large mass will absorb more heat than a body of small mass. I. It will also depend on what again? Nature of the body. quantity of heat absorbed by a body also depends on the nature of the body. If we put these factors together, we say that quantity of heat is equal to or is proportional to mass and also directly proportional to the change in temperature. And therefore, quantity of heat is equal to mc change in temperature, which is equal to mc parenthesis. Take note of this. This is the equation for calculating quantity of heat, where m is mass in kilogram. The mass will be in kilogram. This is change in temperature in degrees Celsius or Kelvin. And C is a constant. It's a constant of proportionality called the specific heat capacity. Specific heat capacity of the body, which depends or describes the nature of the body. C is called the specific heat capacity of the body, specific heat. From this relation, we can define specific heat capacity of a body. From the relation here, which can also be written as H equal to mc change in theta, we can now make C the subject to get H over m change in theta. C is called the specific heat capacity of the body. C is called the specific heat capacity of the body. We now define specific heat capacity of the body as the quantity of heat energy required to raise the temperature of a body of unit mass. Unit mass means a body of 1 kg through a unit rise in temperature. Through a unit rise in temperature. How much heat will a body of mass 1 kg absorb so that its temperature will rise by 1 Kelvin? That amount of heat is called specific heat capacity. All materials have their characteristic specific heat. All materials have their characteristic specific heat. And it is important in material analysis and in building technology. So we take cognizance of the heat capacity of materials. For example, common materials, material specific heat capacity in the unit of its SI unit. Take note of this. SI unit of specific capacity is joule per kilogram per Kelvin. Joule per kilogram per Kelvin. Of course, laboratory work or field work can also be expressed in joule per kilogram per degree Celsius. Yes. Some common materials can have their specific capacity. For example, you have aluminium. It has a specific heat of 900. You have iron. Copper has a specific heat of 450. Iron has a specific heat of 400. Common materials. Common materials. Lead has a specific heat of 130. Mercury in the same range. Mercury has a specific heat of 140 in that range. Water, which is a universal substance. Water has a specific heat of 4,200. 4,200. Glass is a common material. Glass has a specific heat of 670, and so on and so forth, and so on and so forth. So this is the relation for calculating the amount of heat given or taken away from a body at any given point in time. And this is for the specific capacity. For a body of mass 1 kg, if the body has mass other than 1 kg, if it has a mass other than 1 kg, that is not 1 kg, then the amount of heat it will absorb so that its temperature rises by 1 kV will be called heat capacity, not specific heat capacity. And that is C, bold capital letter C, while specific heat is small letter c. And it could be shown that the specific heat capacity and the heat capacity are related. Yes, the specific heat capacity and heat capacity are related. Knowing that specific heat capacity is equal to quantity of heat over m, change in temperature, and the heat capacity, the mass is not 1 kg. So we have the C now equal to 1 over m h over what? Change in temperature. You get it down now? You get it down? So that we can have C equal to mc, where C is heat capacity, and this is called mass, and this is the specific heat capacity of the material. Take note of the relation. Take note of the relation. Okay. Having developed these facts, we will come back to do some calculations. We'll come back to do some calculations with them in the next meeting. We'll come back to do calculation with them in the next meeting. Remember, for gases, we can talk about their molar heat capacities. For gases, we can talk about their molar heat capacities. The molar heat capacity of a gas, having known that heat is given by mc change in theta. But we know that number of moles of a gas is equal to the given mass of the gas divided by the molar mass. Given mass divided by what? Molar mass. Molar mass. That is N equal to M over M. Therefore, M is equal to Nm. Substituting for this for M here, we therefore have the heat of a mole of a gas as Nmc change in temperature. Take note of this last relation. In the next meeting, we will delve into calculations with this relationship established. Thank you for subscribing. Don't forget to share.